For over a century, manufacturers depended on thousands of independent suppliers scattered across dozens of countries, each one a fragile link in a chain that could snap without warning. Tesla is replacing that model with something radically different, and the story of how it did it explains more about the future of factories than about the future of cars. Picture this: a single company designs its own chips, writes its own software, builds its own batteries, casts its own car bodies in one piece, and is now trying to build its own robots. That is not how Ford built cars. That is not how Toyota built cars. That is barely how any manufacturer on Earth has ever operated. And the reason it matters has nothing to do with whether you like electric vehicles or not. It has to do with a problem every single factory on the planet has been fighting for 100 years. The problem of depending on someone else to make the thing you need when you need it at the price you can afford. Tesla's own filings admit something that might surprise you. Even one of the most vertically integrated companies in the world still relies on thousands of parts sourced from hundreds of suppliers. So no, Tesla did not eliminate the supply chain. What it did was something more interesting. It changed which parts of that chain it was willing to depend on, and which parts it decided to bring inside its own walls, under its own control, at its own risk. That distinction is the golden fact of this entire story, the detail almost nobody talks about when they praise Tesla's factories. This is not a company that achieved total self-sufficiency. This is a company that made a calculated bet about where dependency was dangerous and where it was tolerable, and then built its entire operating philosophy around that bet. To understand why that bet mattered, you have to understand what modern manufacturing's biggest structural problem actually is. It is not steel prices. It is not labor costs. It is coordination. It is the sheer difficulty of making a complex product at massive scale while depending on a long, fragile, global web of suppliers, each one with its own delays, its own shortages, its own politics, and its own limits. When one link in that web breaks, the entire system can freeze, sometimes for months. This is exactly what happened during the global chip shortage a few years ago. Factories across the world, from German luxury brands to American pickup truck plants, sat idle because they could not get semiconductors. Reporting from Reuters described how Tesla handled that same crisis differently. Because Tesla writes almost all of its own vehicle software internally, its engineers could rewrite code to work around unavailable chips, swapping in substitutes and adjusting firmware in a matter of weeks, rather than waiting for the original part to become available again. Volkswagen's own former chief executive Herbert Diess publicly admitted that Tesla's ability to adapt so quickly caught the attention of the entire industry. That single moment tells you everything about why vertical integration became strategically important again. For decades, the dominant idea in manufacturing was to outsource everything possible, to stay lean, to avoid owning factories and expertise that someone else could provide more cheaply. But when supply shocks exposed how fragile that model really was, companies started asking a different question. What happens when the thing we depend on simply is not there? Tesla had already begun answering that question years earlier, not because it predicted a pandemic or a chip shortage, but because it needed speed. And speed is nearly impossible when you have to negotiate every design change with an outside supplier. So what does vertical integration actually mean inside Tesla's walls? According to the company's own filings, it means designing and manufacturing its vehicles and energy products, developing nearly all of its vehicle software in-house, building its own dedicated computer hardware to run its self-driving neural networks, and developing proprietary battery cells and manufacturing techniques specifically aimed at increasing supply while lowering cost. It also means direct sales to customers instead of a dealership network, and control over its own charging infrastructure. Every one of these choices removes a middleman, and every middleman removed is one less point where the system can fail. Let's talk about batteries, because this is where the strategy becomes most visible. Batteries are the single most expensive component in an electric vehicle, and for years, automakers were entirely dependent on outside battery manufacturers, the same way earlier generations of car companies were dependent on outside engine suppliers. Tesla's filings state that the company has developed its own proprietary lithium-ion cell technology, along with improved manufacturing processes specifically designed to produce more cells at a lower cost. This is not a small technical detail. It means that as the demand for batteries scales into the tens of millions of vehicles worldwide, Tesla is not simply hoping an outside supplier can keep up. It is building the capacity itself. The company's Gigafactory in Nevada has been described in Tesla's own proxy statement as the largest lithium-ion battery factory in the world. A facility so large that comparing it to a football field barely captures the scale. Multiply that field by dozens and you start to understand the size of the operation. Meanwhile, Gigafactory Texas spans roughly 2,500 acres, an area so large it functions less like a single factory and more like an industrial city with its own supply lines, its own logistics network, and its own internal economy. Now here is where the story gets genuinely strange, in the best possible way. Traditional car manufacturing involves stamping dozens, sometimes hundreds, of individual sheet metal parts, then welding them together into what becomes the underbody of a vehicle. It is slow, it requires enormous factory floor space, and it multiplies the number of suppliers, welding stations, and quality checkpoints needed to build a single car. Tesla pursued something radically different, a process widely known as gigacasting. Reporting from Reuters described how Tesla explored using massive casting machines to produce a single cast piece that could replace more than 400 individual parts that would otherwise need to be stamped and welded separately. Think about what that actually means on a factory floor. 400 parts, each one requiring its own supplier relationship, its own quality inspection, its own transportation logistics, its own risk of delay, collapsed into a single piece of cast aluminum. Fewer parts mean fewer suppliers. Fewer suppliers mean fewer points of failure. Fewer welding stations mean less factory floor space, less labor, and fewer opportunities for a defect to slip through. This is not simply a manufacturing trick. It is an attack on the very structure of the problem. The same structural problem that has haunted manufacturers for a century, the endless complexity of coordinating too many hands touching too many parts. But parts and batteries are only half the story. The other half is software. And this is where Tesla starts to look less like a car company and more like a technology company that happens to build cars. Every modern vehicle, no matter who makes it, is increasingly defined by its software. From the systems managing the battery to the systems managing the infotainment screen to advanced driver assistance features. Most traditional automakers still rely heavily on external suppliers for major chunks of this software. Tesla's filings state plainly that the company develops almost all of its own vehicle software internally and updates its vehicles over the air the same way your phone receives an update overnight. This matters because when engineering, software, and manufacturing are split across multiple companies, every change becomes a negotiation. A supplier has to agree to a new specification, contracts have to be renegotiated, testing has to be repeated. When Tesla wants to change something, it does not need to convince an outside partner. It can move at the speed of its own internal decision making, and in an industry increasingly driven by software rather than hardware, that speed becomes a genuine competitive weapon. The company's approach to artificial intelligence follows the exact same logic. Tesla's full self-driving computer, referred to in its filings as the FSD computer, runs the neural networks responsible for its driver assistance features, and the company has stated it is developing additional computer hardware to support even more advanced processing. Rather than depending on an outside supplier for the brains of its vehicles, Tesla brought that capability inside as well, and now the company is extending this exact same philosophy towards something that sounds like science fiction, but is very much grounded in its actual corporate strategy: humanoid robotics. Tesla's Optimus robot, according to the company's own statements, uses the same underlying artificial intelligence system that powers its self-driving technology. This is the clearest signal yet of where the company believes manufacturing is heading. The next great bottleneck in factories is not simply parts or batteries or software. It is labor, specifically the kind of flexible, adaptive labor that is expensive, difficult to scale, and increasingly hard to find in many parts of the world. If a company can build robots capable of adapting to different tasks the way a human worker can, but powered by the same core software already running its vehicles, it gains yet another layer of independence, this time from human labor markets themselves. Even Tesla's energy products follow this pattern. The company's large-scale battery storage system, called Megapack, is described by Tesla as modular by design, specifically intended to reduce the amount of assembly required once the units arrive on site. Instead of shipping raw components and assembling a complex system in the field, where delays and errors are common, Tesla pushes as much of that complexity as possible back into the factory, where it can be controlled, standardized, and repeated at scale. None of this means Tesla operates in total isolation. The company's own filings state it uses multiple sourcing strategies where appropriate, maintains safety stock for critical materials, and signs long-term contracts to secure raw materials it cannot produce itself. This is the part of the story that gets lost when people talk about Tesla as though it invented some magical formula that eliminated supply chains entirely. It did not. What it did was far more disciplined. It identified which dependencies were tolerable and which were dangerous, and then built internal capability specifically around the dangerous ones. Now compare this philosophy to the rest of the industry, because the contrast reveals exactly why so many competitors are paying attention. Toyota built its reputation on lean production and extraordinarily disciplined supplier relationships, a system so efficient it became the global gold standard for decades. But Tesla's approach is faster moving and far more willing to redesign hardware on short notice, because it does not need to wait on an external partner to agree. Volkswagen operates at massive scale across dozens of brands with deep supplier networks built over generations, while Tesla remains narrower and more tightly focused specifically on electric vehicle systems, giving it more room to move quickly. General Motors relies on modular global sourcing and platform sharing across its many brands, while Tesla keeps far more of its design and software decisions inside the company itself. Ford still leans heavily on the traditional structure of outside suppliers that has defined the American auto industry for a century, while Tesla has tightly coupled its engineering, its software, and its manufacturing into a single continuous process. The most interesting comparison, though, is with BYD, the Chinese electric vehicle giant. Reporting and industry analysis consistently describe BYD as the closest large-scale peer to Tesla in terms of vertical integration, with deep control over its own batteries and electronic components. And then there is CATL, the battery specialist that supplies much of the industry, including in some cases Tesla itself, creating the strange situation where Tesla is simultaneously CATL's customer and, through its own internal battery development, something close to its competitor. What emerges from all of this is a picture that goes far beyond automobiles. Tesla resembles a company like Apple in its obsession with controlling the design of its core technology from the chip level upward. Except instead of building phones, it is building factories. It resembles Amazon in the way it treats logistics and infrastructure as something to be owned and optimized internally rather than outsourced. And it stands in direct contrast to a company like Nvidia, which designs powerful chip architecture but outsources the actual manufacturing to outside foundries. Tesla, by comparison, controls far more of the physical manufacturing process itself. Here is the moment where the perspective shifts, and this is the part of the story that most people miss entirely. The real product Tesla may be building is not the car sitting in your driveway or the one you see driving past on the highway. It may be a new manufacturing system itself, a blueprint for how complex, software-driven, battery-intensive products can be designed, built, and improved without being held hostage by a fragile web of outside dependencies. That reframing changes everything about how you should think about the company. This is not simply a story about electric vehicles outselling gasoline cars. It is a story about whether the next generation of factories, whether they are building cars, batteries, robots, or something nobody has invented yet, will look more like Tesla's model or more like the traditional supplier-driven model that dominated the 20th century. So here's a question worth sitting with. If more manufacturers across industries that have nothing to do with cars begin adopting this same philosophy of pulling critical technology inside their own walls instead of trusting outside suppliers, what happens to the thousands of smaller companies that have spent decades building businesses around being that outside supplier? Does this new model create a smaller number of massive, self-contained industrial giants? Or does it eventually force the entire supplier ecosystem to specialize even further just to survive? That tension is likely to define industrial competition for the next several decades, and it is worth asking yourself which side of that shift you think will win. If Tesla's factory truly becomes the model for the next generation of manufacturing, then the biggest innovation this company ever produced was not the vehicle sitting in the driveway. It was the way that vehicle was built. And once you understand that distinction, you start to see it everywhere, not just in electric cars, but in every industry now racing to answer the same question Tesla asked years ago. What happens when you stop asking someone else to build the thing you need most and decide to build it yourself? To not be caught off guard by what comes next in this industry, join us.